After studying this module, you shall be able to know what a public good is, learn about the conditions for providing efficient level of public good, understand the problem of free rider, and gain knowledge of the various decision methods to determine the supply of a public good. Public goods. A public good is one which is non-excludable and non-rivalrous in nature, and where use by one individual does not reduce availability to others. Common examples of public goods include air pollution, street lights, roads, etc. National defense is another good example. There is one level of national defense provided for all the inhabitants of a country. Each citizen may value it differently. Some may want more, some may want less, but they are all provided with the same amount. Public goods are an example of a particular kind of consumption externality. Everyone must consume the same amount of the good. Assigning property rights can solve externality problems when there are small numbers of parties involved, but not in the case of large group externalities or public goods. When public goods exist, competitive markets cannot be counted on to generate efficient outcomes. Provision of public goods. When to provide public good? Let's explain this with a simple example. Suppose that there are two roommates, 1 and 2, who are deciding whether to purchase a TV or not. Given the size of their apartment, the TV will necessarily go in the living room and both roommates will be able to watch it. Thus, it will be a public good rather than a private good. Let W1 and W2 denote each person's initial wealth, and G1 and G2 denote each person's contribution to the TV. Let X1 and X2 denote each person's money left over to spend on private consumption. Thus, the budget constraints can be written as X1 plus G1 is equal to W1 and X2 plus G2 is equal to W2. Suppose that the TV costs C rupees, so that in order to purchase it, the sum of the two contributions must be at least C. In other words, this means that G1 plus G2 should be greater than or equal to C. This equation summarizes the technology available to provide the public good. The roommates can acquire one TV if together they pay the cost C. The utility function of person 1 will depend on his private consumption X1 and the availability of the TV, that is the public good. Person 1's utility function is given as U1 X1G, where G will either be 0 indicating no TV or 1 indicating that a TV is present. Person 2's utility function is U2 X2G. The roommates may value the services of the TV quite differently. The value of TV placed by each person can be measured by asking how much each person would be ready to pay to have the TV available. This can be done using reservation price. The reservation price of person 1 is the maximum amount that person 1 would be willing to pay to have the TV present. That is, it is that price R1 such that person 1 is just indifferent between paying R1 and having the TV available and not having the TV at all. If person 1 pays the reservation price and gets the TV, he will have W1 minus R1 available for private consumption. If he is to be just indifferent between these two alternatives, we must have U1 W1 minus R1 1 equal to U1 W1 0. This equation defines the reservation price for person 1, that is the maximum amount that he would be willing to pay to have the TV present. A similar equation defines the reservation price for person 2. It should be noted that the reservation price of each person will depend on that person's wealth. That is, the maximum amount that an individual will be willing to pay will depend to some degree on how much that individual is able to pay. As we know, an allocation is Pareto inefficient if there is some way to make both people better off the following by bringing about a Pareto improvement. In the TV problem, there are only two sorts of allocations that are of interest. One is an allocation where the TV is not provided. This allocation takes the simple form W1, W2, 0. That is, each person spends his wealth only on his private consumption. The other kind of allocation is the one where the public good is provided. This will be an allocation of the form x1, x2, 1, where x1 is equal to W1 minus G1 and x2 is equal to W2 minus G2. These two equations imply that each individual's private consumption is determined by the wealth that he has left over after making his contribution to the public good. Under what conditions the TV should be provided? That is, when is there a payment scheme G1, G2 such that people will be better off having the TV and paying their share than not having the TV? In other words, when will it be a Pareto improvement to provide the TV? It will be a Pareto improvement to provide the allocation x1, x2, 1 if both people would be better off having the TV provided than not having it provided. This means U1 W1 0 is less than U1 X1 1 and U2 W2 0 is less than U2 X2 1. Using the definition of reservation prices R1 and R2 and the budget constraint to write U1 W1 minus R1 1 is equal to U1 W1 0 is less than U1 X1 1, which is equal to U1 W1 minus G1 1. And similarly for agent 2, U2 W2 minus R2 1 is equal to U2 W2 0 is less than U2 X2 1, which is equal to U2 W2 minus G2 1. Looking at the left and the right hand sides of these inequalities and knowing that more private consumption must increase utility, we can conclude that W1 minus R1 is less than W1 minus G1 and W2 minus R2 is less than W2 minus G2, which in turn implies that R1 is greater than G1 and R2 is greater than G2. This is a condition that must be satisfied if an allocation W1, W2, 0 is Pareto inefficient. It must be that the contribution that each person is making to the TV is less than his willingness to pay for the TV. If a consumer can acquire the good for less than the maximum that he would be willing to pay, then the acquisition would be to his benefit. Thus, the condition that the reservation price exceeds the cost share simply says that a Pareto improvement will result when each roommate can acquire the services of the TV for less than the maximum that he would be willing to pay for it. This is a necessary condition for purchase of the TV to be a Pareto improvement. If each roommate's willingness to pay exceeds his cost share, then the sum of the willingness to pay must be greater than the cost of the TV. This is to say that R1 plus R2 is greater than G1 plus G2, which is equal to C. This condition is a sufficient condition for it to be a Pareto improvement to provide the TV. If the condition is satisfied, then there will be some payment plan such that both people will be made better off by providing the public good. If R1 plus R2 is greater than or equal to C, then the total amount that the roommates will be willing to pay is at least as large as the cost of purchase. So they can easily find a payment plan G1, G2 such that R1 is greater than or equal to G1, R2 is greater than or equal to G2 and G1 plus G2 is equal to C. It is important to note that the condition describing when provision of the public good will be Pareto improvement only depends on each agent's willingness to pay and on the total cost. If the sum of the reservation prices exceeds the cost of the TV, then there will always exist a payment scheme such that both people will be better off having the public good than not having it. Also, whether or not it is Pareto efficient to provide the public good will in general depend on the initial distribution of wealth W1, W2. This is true because in general the reservation prices R1 and R2 will depend on the distribution of wealth. It is possible that for some distributions of wealth R1 plus R2 is greater than C, and for other distributions of wealth R1 plus R2 is less than C. But in specific cases, the provision of the public good may be independent of the distribution of the wealth. An instance of this kind arises if the preferences of the two roommates are quasi-linear. Efficient level of public good. In order to determine the efficient output of a public good, we must compare the marginal benefits, that is the marginal rate of substitution, and the marginal cost associated with different levels of output. The marginal cost of a public good is the opportunity cost of using resources to produce that good rather than other goods. Because of the non-rival nature of the benefits of a public good, though its marginal benefit differs from that of a private good. It is not the marginal value to any one person alone, since many people benefit simultaneously from the same unit. Instead, we must add the marginal benefits or the marginal rates of substitution of every person who values the additional unit of a public good, and the resulting sum indicates the combined willingness of the public to pay for some defense, that is its marginal benefit. For simplicity, we assume that there are only two individuals, 1 and 2, who benefit from the consumption of the public good. Each person has a marginal rate of substitution curve shown by MRS1 and MRS2. The marginal rate of substitution can be interpreted as measuring the marginal willingness to pay for an extra unit of the public good. The combined marginal rate of substitution curve is derived by vertically adding the individual MRS curve. It is evident from figure that at any level of output where the combined MRS curve lies above the marginal cost curve MC, the sum of the marginal willingness to pay for the public good exceeds the marginal cost, and it is appropriate to provide more of the public good. When MC lies above the combined MRS curve, however, too much of the public good is being produced. The combined marginal willingness to pay is less than the marginal cost over this range of output. Thus, the efficient allocation of public good occurs at the point where the sum of the MRS curves equal the marginal cost, which is illustrated in figure 3.1. In other words, at the optimal amount of the public good as given by G star, the sum of the marginal willingness to pay should equal the marginal cost. It is worthwhile comparing the efficiency condition for a public good to the efficiency condition for a private good. Now, for a private good, each person's marginal rate of substitution must equal marginal cost, and for a public good, the sum of the marginal rates of substitution must equal the marginal cost. In the case of the private good, each person can consume a different amount of the private good, but they all must value it the same at the margin. Otherwise, they would want to trade. In the case of a public good, each person must consume the same amount of the public good, but they can all value it differently at the margin. The free rider problem. Even when a public good is worth more to people than it costs to produce, private markets may fail to provide it. Consider the construction of a dam that will lessen the probability of flooding for members of a specific community. The dam is a public good for residents of the community. Even though it is in each resident's interest to have the dam constructed, there is a good chance that it won't be built if private markets are relied upon to organize the construction. To finance the dam, several residents must jointly agree to contribute, and individuals will realize that they will receive the benefits of the dam once it is built, regardless of whether they make any contribution toward the dam's construction. Each resident therefore has incentive to understate what the dam is worth in an effort to secure the benefit at a lower or zero cost. If enough people behave this way as free riders, voluntary contributions will be insufficient to finance the dam and it won't be built. As the group size increases, it is more likely that everyone will behave like a free rider and the public good will not be provided. A case like this is depicted in figure 4.1. Here, each person's private consumption is illustrated on the horizontal axis and his public consumption on the vertical axis. The endowment of each person consists of his wealth Wi along with the amount of public good contribution of the other person. Since this is how much of the public good will be available if the person in question decides not to contribute. Figure 4.1a shows a case where person 1 is the only contributor to the public good, so that G1, the amount of public good purchased by person 1, equals G, the total amount of public good. If person 1 contributes G units to the public good, then person 2's endowment will consist of his private wealth W2 and the amount of the public good G, since person 2 gets to consume the public good whether or not she contributes to it. Since person 2 cannot reduce the amount of the public good but can only increase it, the budget constraint is the bold line in figure 4.1b. This is an example where person 2 is free riding on person 1's contribution to the public good. Given the shape of 2's indifference curve, it is optimal from his point of view to free ride on 1's contribution and consume his endowment as depicted. Since the public good is a good that everyone must consume in the same amount, the provision of a public good by any one person will tend to reduce the other person's provision. Thus, in general, there will be too little of the public good supplied in a voluntary equilibrium relative to an efficient provision of the public good. Methods to determine supply of public good. Private provision of a public good doesn't work very well, but there are several other mechanisms to determine the provision of public goods. Sometimes people use a command mechanism where one person or small group of people determine the amount of various public goods that will be provided by the populace. Other times people use a voting system where individuals vote on the provision of public goods. Besides this, Vickrey-Clark Group's, that is VCG mechanism of auction is also used, which is a sealed bid auction wherein bidders report their valuations for the items. Summary. Now let us summarize the above discussion. A. Public goods are goods which are non-rival and non-excludable in nature. They are goods for which everyone must consume the same amount, such as national defense, air pollution, and so on. B. If a public good is to be provided in some fixed amount or not provided at all, then a necessary and sufficient condition for provision to be Pareto efficient is that the sum of the willingness to pay, that is the reservation prices, exceeds the cost of the public good. C. If a public good can be provided in a variable amount, then the necessary condition for a given amount to be Pareto efficient is that the sum of the marginal willingness to pay, that is the marginal rates of substitution, should equal the marginal cost. D. The free rider problem refers to the temptation of individuals to let others provide the public goods. In general, purely individualistic mechanisms will not generate the optimal amount of a public good because of the free rider problem. And E. Various collective decision mechanisms have been proposed to determine the supply of a public good. Such methods include the command mechanism, voting, and VCG auction mechanism.